Okay, write down. The derivation we will do. Okay, yesterday I taught very fast, so I am doing the derivation. So note down topic. Potential of planet. Note down. Gravitational potential of planet. Gravitational potential of planet. Note down. Gravitational potential of planet. So potential, what is the formula for potential work done? External work done to go from A to B per unit mass is equal to VB minus VA. So we'll follow this formula. Okay. If you need some external work, if you are going from B to A, A to B, and you are holding mass M, that means you are going from low potential to high potential. See, if external work done is positive, so VB minus VA is positive. So VB is greater than VA. If external work done is positive, are you getting or not? If external work done is positive, mass is positive, right? Mass is always positive. So VB minus VA is positive. So which is greater, VB or VA? VB. So final potential is greater than initial potential. So we have discussed this example. If this is an object, you are taking this object slowly upward like this. So you are doing external work or positive external work or negative external work? Tell me. You are taking it like this. Positive external work. Because what is the direction of mg? Downward. Displacement? Upward. External force? Upward. So mg is doing negative work, external force is doing positive work. Okay. So potential is increasing or decreasing? Tell me. Increasing. Final is greater than initial. Okay, clear? So suppose this is the planet. So this is the surface and this is at height. So where potential is more? Tell me. At height or at surface? Where potential is more? Height. At height potential is more. So as you move away from surface, potential is increasing, right? Increasing. And what is the direction of field? Towards center. Direction of field is towards center. So direction of field is towards center and you are moving away from center. So potential is increasing. Correct or not? And if you move along field, suppose I am moving this object downward. Now I am moving this downward. So potential, I am going from how? Potential is increasing or decreasing? Tell me. Decreasing. Potential is decreasing. So if you move along field, potential decreases. If you move opposite to field, potential increases. Note down this point. If we move opposite to field, if we move opposite to field, potential of point increases. If we move opposite to field, potential of point increases. It means you are going from low potential to high potential. Suppose this is the direction of field. Field is a scalar or vector? Field. Vector. Gravitational field. Force per unit mass. Remember? Gravitational field is force per unit mass. Force is vector. So gravitational field is also vector. So suppose direction of gravitational field is downward. Now two points are there, A and B. Which has high potential? Tell me. A or B? Tell me. A. Correct. Very good. Because same reason, this reason, if work done is positive, so final potential will be more. So suppose I am moving from A to B. Okay, this is A, this is B. This is A, this is B. Now I am moving from A to B like this. So external work done is positive. When external work done is positive, VB minus VA will be positive. So VB is greater than VA. Okay, VB is greater than VA. So B has greater potential, high potential. Potential of B is more, potential of A is less. So understand this, okay? So how potential is related to field, okay? How potential, note down, is related to field. Tell me, how potential is related to field. Tell me how it is related to field. V and G, how they are related? Tell me. Just now you discussed. Direction of field is downward. So if you move along field, potential decreases. If you move opposite to field, potential increases. Okay. So you have written, if we move opposite to field, potential of point increases. One more line you write. If we move along field, if we move along field, potential decreases. If we move along field, potential decreases. This is very important point. This rule is there in gravitation and electrostatic both. Gravitation chapter means gravitational potential. Electrostatic chapter means electric potential. Okay. When I talk about gravitational potential, so gravitational field, if we move opposite to gravitational field, so gravitational potential of point increases. If we move opposite to electric field, so electric potential of point increases. Okay, note down. So just remember what is the relation between V and G. You can remember this diagram also. Suppose this is the direction of G. So which has a greater potential, P or Q? Which has greater potential? Tell me. Which has greater potential? Tell me. Along field potential decreases. Opposite to field potential increases. So which has greater potential? P. Very good. So Vp is greater than Vq. Okay? You can just remember this. So we have one more relation. You just write down one formula. G is equal to minus dV by dr. G is equal to minus dV by dr. Note down. G is equal to minus dV by dr. So suppose this is R. This is R. And this is G vector. And 2 points are there, P and Q. Or this is G vector, so PQ. Now this is G vector, so this is PQ. Okay. So this is R vector and this is G vector. So I am going from low potential to high potential. Okay, I am going from low potential to high potential. Okay, so you can remember this. dV is equal to minus G into dr. Okay, this is the formula. So for derivation, we will use this formula. Okay, so the x component, note down. Suppose this is the direction of G. and this is the direction of dr. So if I move along dr, if we move along dr, tell me potential increases or decreases? If we move along dr, potential increases, correct. So I will write dv is equal to minus g dr. Now g is leftward, g is leftward, so I will put here minus g. Okay, so minus of minus g dr. You can assume it to be vector. Okay, this is vector here. So g is leftward, dr is positive. So g is leftward means g vector is leftward. So it is minus g. So minus minus plus. So we will get, now this is the magnitude. Okay, this is the magnitude of g. So dv is equal to g dr. Okay. So opposite to field, potential increases. If I move opposite to field, potential is increasing. Okay, next you write down. Now planet. Come to planet. Okay, suppose this is the center and this is the surface. If I move center to surface, now you tell what is the direction of field. Center to surface, what is the direction of field? Center to surface or surface to center? Field. Field. Downward. What is the direction of field? Towards center. Very good. So field is towards center. And suppose I am moving center to surface, dr. So I am going from low potential to high potential or high potential to low potential? Low to high, very good. Because the direction of g vector is towards center and I am moving center to surface. So which has high potential, center or surface? Surface, very good. So note down. G vector is towards center. G vector is towards center of planet. You can write Earth also. Center of planet or Earth. All planets are same only. Rock. They are made up of rock, solid. Okay. I am talking about gas. Gas also same thing. Gas planet or solid planet. They have mass. Okay. Okay. Fine. So G vector is towards center of planet. If we move center to surface, potential increases. Potential increases. Okay, note down. Potential increases. So potential of surface is greater than potential of center. Okay, potential of surface is greater than potential of center. So first you remember this point. Okay, center and surface which has high potential, surface. And when you move away from surface, further away, potential is further increasing. Correct? You have discussed this. So when you move away from, if you move away from surface, so potential is increasing. So where potential is maximum? Infinity. Potential is maximum at infinity. So maximum potential is at infinity. Maximum potential is at infinity, very far. So where potential is maximum for planet? Infinity. So where potential is minimum for planet? Center. So minimum potential is at center of planet. Okay, memorize this. Maybe assertion reason type questions are there. Gravitational potential is maximum at center. True or false? False. Correct. Very good. maximum potential is minimum at center. True. Okay. Maximum potential at center. Potential at center is minimum. So true. Potential at infinity is maximum. True. So these 2 3 points you memorize. Okay. Now I will come to derivation. So inside planet, how to find potential? Inside planet, how to find potential inside planet? How to find potential inside planet? So this is the planet. This is the center. Now I am talking about this point. This is the center. This is the surface, and this is the point. The distance of this point is r. Distance of this point is r. Now this point is suppose P. Okay, this point is P. So what is the potential here? Question is what is the potential here? And suppose this point is Q. So potential of Q I know. What is the formula for potential at Q? Minus Gm by R. We know this. We have derived this. If point mass is there at r distance, what is the potential? Minus Gm by R. We have derivation finished. Okay. So planet surface potential is minus Gm by R. M is mass of Earth, radius of Earth. Now what is the potential at P? We are finding. So we'll do derivation now. So see, suppose I am going from P to Q. If go from P to Q, so suppose I am here. I move very small displacement dr. I am going from P to Q. Now I am going very small displacement dr. So the change in potential dV is equal to minus g vector into dr. Now what is the direction of g vector here? Direction of g vector opposite left. So towards center, g vector is towards center, and I'm going away from center. So you write here minus g. Okay. Now what is the value of g? Now g is the magnitude here. Now here g is magnitude. What is the formula for g here? Tell me. At r distance, what is g? Tell me. You know what is the formula at r distance? Okay. Can you tell me depth? Depth formula you tell. What is the depth formula? Correct. Good. So what is the depth here? If distance from center is a small r, so what is the depth? R minus r, correct? Are you getting or not? So depth is r minus r. Distance from center is r, small r, and distance from surface is d. So what is d? Capital R minus small r. So put here. So g r minus d by r. So r minus d is a small r. So g dash is g into r by r. So you write here g dash also. Okay. So this is gr by r dr. Okay. So this is dv. dv is equal to gr by r dr. So what is g? G is the gravity on surface. Gravity on surface. Okay. Now you integrate it. Now when you integrate, from where to where you are going? P to Q. So what is R value for P? R. What is R value for Q? Radius of Earth. Radius of planet. Like this. Okay. I am going from small r to capital R. And dV what you write? Potential of P to potential of Q. Understood? This you understood? At r distance, small r distance, what is the potential? Vp at capital R distance, what is the potential? Vq, that is surface, correct? So you can write, now tell me left side, what is the integration? Tell me left side. Uh, Vp minus Vq or Vq minus Vp, left side? Vq minus Vp, very good. Okay, very good. Okay, small g by R. R dr integration, small r to capital R. Now you do it. Do this integration. What do you write? R square by 2, small r to capital R. So Vq minus Vp is equal to g by R, g by 2r, capital R square minus small r square. Okay, so Vq minus, take this left side, minus Vp right side. So Vq minus g by 2r, r square minus r square is equal to Vp. We have to find Vp only. We have to find Vp. This, okay, this we know, and I am finding Vp. Surface we know. Surface means Q. What is the formula for surface? Tell me. Minus Gm by R. And what is the formula for G? G on surface? Gm by R square. This is small g. Then this is R square minus R square by 2R. So now take common. What common you can take? Minus Gm by R common. So 1 plus minus Gm by R common. So 2R square here. R square minus R square numerator. Okay. So this is Vp. So minus Gm by R 1 plus. Okay. Now solve this. So 2R square into 1 plus R square minus a small r square by 2R square is equal to Vp 3R square minus R square by 2R square. Okay, minus Gm by R. So this is Vp. So this is 3 by 2 minus R square by 2R square. Clear? Minus Gm by R is equal to Vp. So this is potential of surface. Potential of surface in the bracket 3 by 2 minus R square by 2R square. Potential of point P. Now take 2 also common. So 1 by 2 potential of surface is equal to 3 minus R square by capital R square. Now take 3 also common. So what you get? 3 by 2 potential of surface is equal to 1 minus R square by 3R square. This is the formula. This is the formula for Vp. Note down. Vp. So potential inside planet at distance small r from center is equal to 3 by 2 potential of surface bracket 1 minus small r square by 3r square. This is the formula. Okay, are you getting? Note down. So this is very important formula. So now you tell me what is the potential at the center. Find potential at center. What is the value of small r for center? 0. Very good. Okay. So what is the potential at center? 3 by 2 times potential at surface into 1 minus small r is 0 and 1 minus r square is 0, 1 minus 0. So what is the potential at center? 3 by 2 times potential of surface. Okay, clear? So your answer is 3 by 2 into potential of surface. Potential surface, you know what is the answer? Potential surface minus Gm by R. So potential of center is minus 3 by 2 Gm by R. Okay, note down potential of center. Okay, clear? Okay, okay. Note down, note down. So regarding potential, you just remember few points. If field is leftward, so VB is greater. VB is greater than VA. 2 points are there. Field is left side, so B has greater potential. If you are moving like this, so you are going from high potential to low potential. If you are going like this, you are moving from low potential to high potential. Okay. If you move along field, so potential is decreasing. If you move away from field, opposite to field, potential is increasing. Okay, just memorize this. Okay, fine. Okay, fine. So just remember these points. So same type of derivation will be in electrostatics also. So the direction of field is towards center. I am going from center to surface. So potential is increasing. So at r distance, what is the g vector? At r distance, g vector is gr by r, left side. The relation between dv, g vector and dr vector is this. Okay? dv by dr is equal to minus g vector. Now g vector is left side, so minus g. G vector is minus g, g dash. Okay? G dash. Here gravity is g dash. So minus minus plus. So dv is equal to g dash dr, and g dash is gr by r. Okay, so gr by r. Now integrate. Now I am going from p to q. P to q. So small r to capital R. Small r to capital R. So Vp to Vq. So Vq minus Vp is equal to this integration you do. Okay, carefully you solve. Once again you practice. Okay, you will get this formula. Okay. So Vp this is Vp. Okay. So now you remember this formula. Okay. Now any question is there, you use this formula. So I am giving one question, you solve. Find potential at depth r by 3. Find potential at depth r by 3. Okay, solve. Find potential at depth r by 3. Find gravitational potential at depth r by 3. Depth means distance from surface. Depth means distance from surface. So what is distance from center? How much? 2r by 3. Very good. So distance from surface is depth. So distance from center is 2r by 3. Note down. Okay. Solve and tell me your answer. Distance from surface is depth. Distance from center is this r smaller. So formula, potential inside is equal to 3 by 2 times potential surface 1 minus small r square by 3 capital R square. Okay, this is the formula, no doubt. So you can calculate this separately. So small r square by 3 capital R square. How much this is separately you can calculate here. So small r is 2r by 3. 2r by 3 square by 3r square. So 4 by 9 r square by 3 r square. So r square I should cancel. So 4 by 9 whole divided by 3. How much? 4 by 9 whole divided by 3. Tell me. 4 by 27. So this is 4 by 27. So 3 by 2 potential surface 1 minus 4 by 27. So 1 minus 4 by 27 how much? 1 minus 4 by 27. 23 by 27. Now 3 by 27, 1 by 9. So 1 by 9 into 23 by 2 Vs. Okay, so 23 by 18 Vs. So what is Vs? Vs you know, minus Gm by R. This is the answer. Minus 23 by 18 Gm by R. Okay, clear? Give me book. We will see some question like this. So potential inside planet, note down. Potential inside planet. So yesterday I gave this question, then the power went. Same question we'll solve now. Okay, direct question is not there. Okay, so there is no direct question. Okay, one PYQ is there. Okay, so 15th question, page 5 in 11. Page 511, question 15. So this is not inside, it is outside question. Potential outside, tell me what is potential outside. Suppose R distance. What is potential here? Tell me. Minus Gm by R. And small r can be written as, what is small r? R plus H. Very good. And what is the formula for field? Field here? Gm by R square. Gm by R plus H whole square. Correct. Good. Very good. Okay. So question is, at what height from surface, at what height from surface gravitational potential is minus 5.4 into 10 raised to 7 joule per kg, and field is, and gravitational field is 6 meter per second square. Okay, solve. Potential is negative quantity, remember. Potential is negative quantity and gravitational field is a vector. So magnitude is given. Okay. Direction we know it is towards center. So this is the magnitude of field. Direction of field is towards center. So magnitude is this. So this came in 2016. So (1600, 1400 kilometer, 2000, 2600. Okay, solve. So how to solve? It is easy question. Okay, it is very easy. You just think how you can solve. You write this formula. When you write, immediately you will understand. It is easy. Okay, what is the formula for V? Minus Gm by R plus H. This is given as minus 5.4 into 10 raised to 7. What is the formula for magnitude of G? Small g. Gm by R plus H whole square. This is given as 6. Now you know what to do. You separate R plus H here. So Gm by R plus H into R plus H, correct? Is equal to C. And Gm by R plus H, what is this? Gm by R plus H is this. Minus minus cancel. Gm by R plus H is this. Put here. Easy, right? So what is the answer? Now you solve. 5.4 into 10 power 7 divided by R plus H is equal to 6. So what is R plus H? Now solve. Six you take left side. 5.4 into 10 power 7 divided by 6. 5.4 by now solve. 0.9 into 10 power 7 is equal to R plus H. Now this is in meter. Okay. This is in meter. So 10 power 3 meter is 1 kilometer. So this is 0.9 into 10 raised to 4 kilometer. This you understood? 10 power 7 means 10 power 4 into 10 power 3. Correct? Is equal to R plus H. So this is how much kilometer? 0.9 into 10 power 4. How much? 9,000. Correct? Correct? So 9,000 So R value you put. So 9000 is equal to 6400 plus H. So H will be 9000 minus 6400. Okay, like this you have to solve. Radius of Earth is given 2600 kilometer. This is the height. Okay, clear? So practice. Okay, so PYQs are very important. Past 10 years, every year one or two questions are there in gravitation. So how many questions are there from gravitation? Approximately 20, around 20 MCQs are there in PYQs. Okay, clear? Okay, fine. So this so graph we have discussed. Okay, take break. We'll continue. Okay, so this gravitation over. I just derived. After break, we'll do calorimetry. We will do. Okay, calorimetry. Note down. The thermal properties of matter. Okay, chapter 12. Module 2, calorimetry. Okay, module 2. Okay.